Hi there, welcome back to the breadboard and another episode of product reviews. Today we have a USB camera that was sent to me from webusbcameras.com. They specialize in security surveillance type of cameras, and they have quite a wide range from basically a PCB with a camera mounted on it similar to a Raspberry Pi camera or something, but with a USB interface, right up to complete surveillance solutions, fully packaged cameras for outdoor use, indoor use, etc. The one I have is 8 megapixel. We'll go into the details when we're sitting at the bench. Now, right now, I'm actually simultaneously recording at 15 frames a second from the USB camera and on my main HD 1920 by 1080 camera. And I'm going to put them up side by side, and I'll switch around the main view so that you can see the difference. But as you can see in this light, it is actually producing quite a good quality picture. We'll go into the details of its luminous sensitivity and all that kind of stuff in a moment. And the screen up here is actually just a rendition from my Microsoft Surface that is actually showing the feed from the camera as well. It's not going to be at the same resolution because obviously that screen is only 1080p, but I've got it directly recording with some webcam software onto the hard drive, so we'll have a look at that too. But it's at full resolution, so I won't let it run too long because it will probably fill up my hard drive. Anyway, the camera comes in a nice neat little box. The company approached me to see if I wanted to review them, and I said I would. It looked very interesting, and I was looking for some kind of solutions for monitoring my CNC equipment that I have in my garage, and also to have something that would be suitable for monitoring things like 3D printers and to do time-lapse captures and things like that. So one of my requirements was that it not only ran on Windows, but that it could also run under Linux and be able to be used with MJPEG capture utilities and things like that as well. So the first thing, I guess, is to have a look at the physical aspects of the camera, and I'll have to stop recording from the webcam in order to do that. And then we'll go on the website, have a look at some of the technical specifications. And one of the other things I also did, because the one I got was not in an enclosure, I designed a 3D printable enclosure for the camera with a standard 1/4-20 camera type mount on the bottom of it, so that I could easily use things like GoPro mounts or tripods and other things to set the camera on. It's actually sitting on my tripod right now. I don't know if it's in view, but it's sitting, no, it's just out of view. Let me just zoom the camera out a little bit. There, that little green thing right there is the camera that's recording in the alternate window. So without further ado, let's get to the bench. I'll take it back off the tripod and we'll have a closer look. I think we'll go to the website first and have a look at the specifications of this, because it is quite impressive. As I said, it's 8 megapixel camera. At 8 megapixels, it'll do about 15 frames a second, but it only gets faster from there. So let's go have a look. Okay, so time to have a look at the specifications on the ELP website. So here we are, www.webcamerasuSB.com, and this is the actual module that we have been looking at just a moment ago. So let's just scroll down and see what other information is provided. I know we're looking at things like full maximum resolution and stuff like that. So the sensor that is used for this camera is a Sony IMX179, 1/3 of an inch, 1.4 micrometer pixel size, image area, max resolution 1264 by 2448. But if I look at the actual footage that I took using the camera, I'll tell you that the resolution that was doing was 2592 by 1944. The one thing though, when you are running at maximum resolution, is you're limited to about 15 frames a second. So you have a choice of 2 compression formats, MJPEG or YUV2. We'll show you an example in a minute running this on a Raspberry Pi as a time-lapse camera capture. fully supported there and pretty much automatic configuration. So you can see all the different resolutions that are supported, nothing more than 30 frames a second, but for most videoing purposes that is more than enough. Sensitivity down to half a lux, basically, minimum illumination. So not really low exposure, but you can supplement that with lighting and things as well if you want. And of course there are, if you want really low light level, there are alternative cameras from ELP that will do that for security reasons and things. This one is a high resolution camera, and as such it probably requires a little bit more illumination in order to work well and get a good quality picture. USB 2 high speed, so it's not a USB 3 device, it's a USB 2 device. Based on the specs here, it looks like it should also work with my Android phone, so I will give that a little try and see if it will pick up on it. I have an Android Samsung Galaxy S5. Adjustable parameters, brightness, contrast, saturation, hue, sharpness, basically the usual range. I did find with the Raspberry Pi that I couldn't adjust a lot of these so easily. Lens parameters, about 1/3 of an inch, f3.5, 75 degree field of view. Working temperature -10 degrees, up to +70. So it probably wouldn't work outside here right now. It's been down to below -20 in the last few days. Board size is 38 by 38, but as you can see with the image, you can break out the outer mounting area. If I go back up to the board, you can break off the outer mounting area and have this 32 by 32 mounting style as well. Operating systems that are supported, you can see here it pretty much supports everything. It doesn't mention Windows 10 in here, but the example I've just shown you, it was happily working with Windows 10. I've also used it with Raspbian Linux, so it works well with there. And I will give it a quick go with Android 6, I think is what's running on my Samsung. So that's the specifications. It's got some pretty good reviews. Here's one that's actually been put up on their website. You can have a look at that yourself. I will provide a link to this website. What other products do ELP provide? Well, here you can see quite a range of different cameras, 1080p, 5 megapixel, 1.3 megapixel, 720, 8 meg. Autofocus, dual lens for 3D. That's an interesting thing. So you could do some 3D imaging and the likes. IP connected cameras. So if you want to connect via the network, they have that available as well. As I mentioned beginning of the video, they also supply some cameras that are not in modules, that are ready for outdoor mounting and stuff like that. Okay, so I fired up the webcam application on my main PC. So this is currently using my Microsoft HD webcam. There you go. Looking at my whiteboard and things just for an idea. And if we look at the settings, you can see that it will only go up to about 1920 by 1080, 30 frames a second for video recording. Of course, it will do higher if I take a snapshot. So if I just literally click a picture of that, and we'll have a look at that in a moment. Now, if I then switch the camera using the little button over here, I have the ELP 8 megapixel camera looking at basically the same place. And here you can see, first of all, it's much wider on the screen in the field of view. But if I look at the potential resolution now for video recording, it will now go up to 2592 by 1944 at 15 frames. It won't do 30 frames. I'll go back to the other one a second. You'll see that that's 1920 by 1080 at 30 frames a second. So Windows 10 is reading it slightly differently. That is for sure. It's driverless, so there's nothing you can do, but these are the only settings that Windows is allowing for the video. It's a 15 frames one, even though we know that if it went down to 1920 by 1080 it can do 30 frames. Anyway, the other thing is of taking a picture, of course, from here too, and that will allow it to take a picture at the full resolution. So I'm going to do another snapshot. There we go. By the way, there's my hand in that one. You can see a slight blur because it's only doing 15 frames versus my 30 frames a second Microsoft HD Cam is doing 30 frames, so it's a little less blurrier. Anyway, let's get back and have a look at what these images did. I'm going to put this camera down now, and you can see that that actually took a snapshot of only 800 by 600, and this one took a snapshot of 3264 by 2488. So let's just open that up, and I'll just flip. You can see now the difference in scale just on the same image here. I'm just doing this full screen because by the time this renders and gets out to the YouTube channel, it won't quite look the same, but you can see here that it is quite a considerable improvement on what it can take from a webcam perspective, which is great. Now, the other thing I wanted to quickly show you was an example piece of footage from a Raspberry Pi on Octopi. So I basically set up Octopi. I just configured the standard USB camera. So here's all some of these have got the individual images that were taken. So in here you can see there's about 1,300 images. If I look at the properties of these, you can see that they are at the full resolution. So 3,264 by 2448. And if I open one of these, and it wasn't terribly good lighting. I haven't got a good light set up yet. Let me just scroll down to something that has a piece of an image in it. So you can see there me in the background. I think the focus is slightly off. I think this is before I cracked the paint seal and adjusted the focus slightly, because you can see my hairy chin is nicely in focus, but the little cube that I'm printing here, I think this was the first attempt at printing a box for the camera actually itself. So anyway, this is an example of the full resolution picture. I'm actually just scrolling through the images here. This was just at the very end. As I said, I'll make this file available to you. I just used a pair of calipers and measured the dimensions of the camera, and then I created the model in Fusion 360, outputted it as a still file, and just simply printed it. And I broke it into two halves. So there is the case that I 3D printed. You've already seen a picture of that. If I turn on the sketches, turn off the objects, turn on the sketch, so you can see I just simply based it on two sketches. One is the outline, so I have the hole big enough for the lens to fit through. The grills are for the back, edge little mounts to go to the holes that are in the PCB. Reasonably thick wall. I then added a second sketch plane, which was at right angles to the back, where I made the hole for the thread and a bit of a thick piece of plastic around it to give it some strength. And then basically going through all of this, if I just turn back on the objects again, you'll see it's not what I wanted to do. I just extruded and added chamfers and stuff like that, and that was pretty much it. If I just turn off the back, look inside the front of this, you can see there just nicely modeled with the threads and everything else. So printing it this way up is the way to do it, of course, so that you don't have any support material required. And with the back of it, printing this side down, so that way up. That way again, no support material is required. Rounded off the inside edges just for aesthetic reasons, none other than that. And again, just simple geometry allowed me to fairly quickly create this case for it. So as I said, if you want to use the case, go for it. No constraints, just if you do republish it anywhere, make sure you refer back to me, please. Very happy with the camera. It works very well. I will be doing a lot more with it going forward. The price, oh, that was an interesting thing. Price. How much does this thing cost? So if we go to look on Amazon, so ELP for this 8 megapixel one, there we go. Currently this is $59, so $60 plus $15 shipping. Okay, so here is the module. I just took it off the camera tripod. It's still in its case that I created for it. These are 4 mounting holes that you could actually put some very small screws through to clamp it all together. You can see it's quite thin. I don't know if I have a ruler handy. No, I don't. But anyway, back just comes off to gain access. But the main connection for the USB is just on this little wire here, so that can just unplug. It also means that it'll be relatively easy to make up your own longer cable if you need it. The slots on the back here, in case you're wondering, are for allowing a little bit of airflow. Not that it actually gets warm, but just in case. So opening it up, this is the camera module itself, ELP USB 8MP02G-L75. So let's just put the case aside. We can look at that separately. So this is the back of the camera module. As you can see, there's not a huge amount there. There are potentially options for things like you know, an LED and things like that, but they're not included in this particular module. It's only about the camera right here. So I don't know if I can get into this any further. Just peel back this label a little bit. There we go. So we've got the main processor. There's no marks on this chip here. I'm going to try and see if there's any marks on any of the other ones. No, not that I can see. I will have a closer look anyway and try and figure something out. And what else is on this side? Well, there's 2 screws. They look like they hold on the lens assembly. On this side of the board, of course, there's nothing except the lens, and the CCD is probably going to be under there as well. We'll just grab a little screwdriver and we'll see if we can just take that off and have a look. I do want to be careful with this because I do want to be using it again. So I will be careful not to get any fingerprints on the CCD and things. Okay, that's the 2 little screws out. Let's just turn this around and pop the top off, and there is the CCD. So that's pretty much all there is on this side of it. The lens will have a UV filter in it, as well as the focusing mechanics. It does come pre-focused, probably for optimal use as a web or security industry camera for the longer focal distances. I did actually break the focusing seal. You see a little bit of glue just in here. Just a little bit of gentle pressure and you can crack it off so you can adjust the focus, because I was trying this out for stop motion photography on my 3D printer, which means I needed to focus a lot closer than what the camera was set for. Minor thing and very easy to adjust. You can always put another dab of glue on once you've adjusted the focus, or you can just simply not touch it at all. But that's pretty much all there is to look at. The case that I built for this, I basically took some calipers, measured the distance between the holes, and also the dimensions of the board, as well as the thickness of the board, diameter of the lens, and I went into Fusion 360 and created this little case. So it's designed so that it actually fits when it's sandwiched together. The little tabs here push and leave virtually no gap for the PCB. So, and it's also a fairly tight fit. As you can see, it doesn't fall out. But I think after a few times of pulling it in and out, it might get a little bit loose. And then even though I printed a thread of a quarter by 20, I still took a quarter 20 tap and ran it through afterwards just to smooth it off a little bit. But that was pretty much it, and yeah, it fitted perfectly. So I will make the file for this case available on Thingiverse, so that if anybody else has one of these cameras and they want to download it, they're quite welcome to modify it. If I do ask if you do modify it and use it for something else, please share, and credit back to my original design if you use it for something and post it elsewhere. But that's it. So let's go look at the specifications on the website and trying a couple of other things out. I will also link to some of the footage that I took using the Raspberry Pi at the highest settings of this. The webcam footage that the Microsoft Surface took was only 2000 and odd by 1000 and odd. I'll post the actual resolution up right here. I'd have to go check on the file. It wasn't at the maximum that this CCD can handle. So what I will do is I'll try and grab some still shots of higher resolution and post them on my website, or try and make them accessible to you through Bitbucket or GitHub or something like that.